All right, today we're going to cover factoring one more time. And our focus will be on factoring what's called perfect square trinomials. Now, when you're factoring these perfect square trinomials, it's kind of a lot simpler than what you've been doing, especially what you had to do yesterday when there was a lot of trial and error involved. All right, perfect square trinomials will look like one of three ways. The first type of perfect square trinomial you'll see will look like a squared plus 2ab plus b squared. Now, a perfect square trinomial that's in this format will get factored to a plus b squared. And let me show you what I mean by that. As soon as I can find a good example to show you. Well, we could say that this is 4a squared I'm doing this wrong, I think. They don't even have an example in here to show you with this type of problem. Let's see, so this is going to be 2. Nope, that's not one. Give me just a second here. Let's see if we do. Times 2 is a 4. No. This will be a 8a plus 8a plus 16. So 4a squared plus 16a plus 16. Come on, eraser. This is going to be a long day. Okay, if you're asked to factor a trinomial and you look at the trinomial and the number that's in front of the A is a perfect square, meaning its square root is a whole number. And the last term is also a perfect square, meaning that its square root is a whole number. The square root of 4, that's equal to 2. The square root of 16, that's equal to 4. So that makes these two perfect squares. When the first term is a perfect square and the last term is a perfect square, you can factor these, and your factors will look like this right here. It will be a binomial squared. So in this case, the factors of this trinomial would be this 2, the square root of 4, which is 2a. Since this in the middle here is plus, since everything in here is plus, this would be plus. And the square root of the last term would go right here. So the factors of 4a squared plus 16a plus 16 are 2a plus 4 squared. So what I'm trying to say is, again, if this first term is a perfect square and the last term is a perfect square, then the square root of the first term goes here. Goes here with the corresponding variable. And the square root of the last term goes here. So if you had, only if they're both perfect. They both have to be perfect squares. Yes. They both have to be perfect squares. If you had like a 9x squared plus, what's this? 3 times 6 times 2 times 18 times 2. All right, so 9x squared plus 36x plus 36. This would factor to the square root of 9, which is 3x, plus the square root of 36, which is 6 squared. And it would also work with something like b squared plus times 7 times 2, so 14b. All right, this one right here. What's in front of this b squared? There's a 1 there, right? And isn't the square root of 1, 1? All right, so that's a perfect square, isn't it? And isn't 49 a perfect square? So look what this factors to. This is just b plus 7 squared. Good with that? If the first term is a perfect square and the last term is a perfect square, then the square root of the first term goes here. Square root of the last term goes here. Everything has to be plus. And you have a plus in your factor. That's the first type of problem you'll see. Second type you'll see will look like a squared minus 2ab plus b squared. And now when it's in this format, and what I mean by this format, I mean that perfect square in front of the a squared or x squared, and a perfect square at the end. This will factor to a minus b squared. What the middle number is it's the square root of what's in front of the a squared times the square root of what's in front of the b squared times 2. Yeah.
Why is it minus b?
Well, this is kind of a pattern type thing. All right. Do you see how this is a perfect square plus and then another plus and a perfect square? So this had to be plus. If it's a perfect square, a minus, and then a plus, a perfect square, then this has to be a minus.
What is it both minuses? It's a minus 2.
That changes everything. If they're both pluses, this is plus. If it's a minus and a plus, this is a minus. If it's anything other than that, you got to factor it like you did yesterday, where you're kind of trial and error, okay? This shortcut will only work when plus plus and a plus, or a minus plus and a minus. So if you were to take, if we go back to this b squared minus 14b plus 49, see how it falls into this format? We can still use the b and the 7, but it's got to be b minus 7 squared. Because what ends up happening is you're looking for factors of 49 that add up to 14, right? So if you were factoring this the way you did on Monday, you'd do 1 and 49. There ain't many things that go into 49 evenly. You got 7 and 7. Well, here's your only two factors that add up to 14 and multiply to 49. But it's got to be a negative 14. So if you're going to factor this, you would do b minus 7 times b minus 7. Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 is negative 14. And b minus 7 times b minus 7 is the same thing as b minus 7 squared. So what it ends up being is a result of you doing so much factoring that you can recognize a perfect square trinomial and factor it without trial and error. All right, so this is just kind of a shortcut for these perfect square trinomials, but they have to fall into 3 specific formats. This was the first format. Perfect squares with a minus and a plus. Perfect squares with a plus and a plus. Okay? So if we went to this 9x squared problem that we already factored, if we got 9x squared plus, be minus 9x squared minus 36x minus 36. I see a perfect square in the front. I see a perfect square at the end. I'm sorry, plus 36. Perfect square in the front, perfect square in the back. All right, so I go 3x minus 6 squared. See the difference in the two? Plus plus gives me a plus here. Plus plus gives me a plus here. Minus plus gives me a minus in the factor. All right, minus plus gives me a minus in the factor. So if you had something like 25a squared minus 120a plus 144. All right, instead of spending a bunch of time finding factors of 144 that'll add up to negative 120, hopefully you're going to recognize that 25 is a perfect square, and so is 144. And it's in the format of minus plus. So it's a perfect square trinomial. So our first factor is going to be a 5a minus the square root of 144, which is 12, and it's all squared. Make any sense? Make some sense? All right. The third type of problem you'll see that's related to these perfect squares is an a squared minus a b squared that you have to factor. Perfect square minus perfect square. Those factors end up being a plus b times a minus b. Meaning there's no middle term here. There's nothing times ab. There's no 120a in the middle, and there's no 36x in the middle. There's not a middle term. It's a first term and it's a last term. All right? An example of that will look something like x squared minus 9. X squared minus 9 is a perfect square, and its factors are x plus 3 times x minus 3. Now, and if you go back to the rule we were using on Monday, I need factors of 9 that add to, my middle term is 0. All right, this x squared minus 9 is the same as, it's the same as x squared plus or minus 0x minus 9. So I need factors that multiply to negative 9 but add up to 0. All right, so a positive 3 and a negative 3 give you a 0, and a positive 3 times a negative 3 give you the negative 9. Okay, so third type of perfect square, when there's no middle term, and the first term is a perfect square and the last term is a perfect square. And you'll see these in all shapes and forms. This could be 100 b squared minus 121. Those are both perfect squares. So this is 10b plus 11 times 10b minus 11. Your square root of 121 is equal to 11. Your square root of 100 is equal to 10. But there's no middle term. So our factors are plus and minus. (25) x squared minus 49. No middle term. So we get a 5x plus 7 times a 5x minus 7. Make sense? All right. Anybody need to see another example of any of those three special types of trinomials that need to be factored, or that can be factored? Looking over some of those papers that y'all turned in yesterday or didn't turn in. I don't know if it was a lazy Tuesday or you were really struggling with the factoring. So you're going to have to factor on the quiz on Friday. So what I'm going to do here is, for today's assignment, if you feel like you don't need any more practice at all on what we did yesterday, then I guess don't do the first part of this assignment because you probably did it yesterday. But on page 221, all right, 41, 42, 43. I'm going to assign 41 through 44 again. If you feel like you were really struggling yesterday with that factoring, then I want you to do those 4 problems again. Okay? The only way that you can ever get better at factoring trinomials is to keep factoring trinomials. And what you'll develop in your own brain is your own little pattern or your own little checklist for finding the correct factors. And you'll have a little aha moment, and then you'll get a little bit better at it, and then you'll get a lot better at it, and then you'll be good at it. And if you're going to be a math person and you're going to major in something in the sciences field when you go to college, and you're going to get a Bachelor of Science degree, you're going to have to take a bunch of math classes. And you're going to have to apply problem-solving skills exactly like you do in factoring trinomials for a long time, all the way through your senior year of college. Okay? So if you're doing anything in that field, you're going to want to kind of master this technique before you move on, and not just blow it off and go, I'll learn it next time. You might as well just learn it now. It'll be a lot easier in the long haul. All right? So if you struggled with yesterday's assignment, do these 4 again. And then I want you to practice some of today's stuff, which is 47 through 55. All right? You're going to put it in the basket. Usual. Shouldn't have to say it anymore. Or you're going to email me a picture. So this first part, this is optional. If yesterday's assignment was easy, you ran right through it, you checked your answers at the bottom, they were all right, you don't need to do it again. You're old enough to figure it out whether you need more practice or not. If you really struggled, or you struggled at all with yesterday's, do those 4 again right now. Okay? Do those 4 again, and then do these, I don't know, these 9, 47 through 55. Everybody got that? Those are your directions / assignment for today. I really like putting them colors around the assignment. I don't know why, but well, we did this Avid thing years ago where it was like this scarecrow thing that we were supposed to dress up.